Okay, well, welcome to the San Francisco Bay Area ISSA July 2022 meeting. We're here at Sysdig and wanted to thank them again for providing this space. And our speaker today is Ed Wilder James, who is the Vice President of Open Source Ecosystem at Sysdig. And Ed brings more than 20 years of technology, content, business, and strategy experience in public and venture-backed private technology companies. Before joining Sysdig, he led supporting the global open source community and guiding strategy for key open source projects, including TensorFlow, Go, and Kubernetes. Prior to that, Ed spent time in big data and analytics at Silicon Valley Data Science and was a conference chair at O'Reilly Media. Ed was the founding chair of TensorFlow World and O'Reilly's Strata Conference on Big Data and Data Science, as well as chair of the O'Reilly Open Source Convention. He was the chair of OSCon for 6 years and is a former Debian and GNOME contributor. Thank you again, Ed. Take it away.
Thank you so much. It's a pleasure to be with you all. Sorry I'm not there to be down in person. Well, not in the Cayman Islands. I'm at home up in one country, which is very pleasant too. Not a bad place to weather out multiple pandemics. So, yeah, I'm really honored to be here and looking forward to a conversation that I hope will be a dialogue between us. My time actually in security is relatively brief. I have much longer history in open source, so I hope that, like, between the dynamics of everyone in this room, we might make some interesting discoveries and reach some interesting points of view. So thank you for that wonderful introduction. I always feel slightly weird hearing my own bio read back to me, but I would love to just say where I'm coming from to give you a bit of perspective. Most of all that stuff is in here, what you've just said. My job, you know, when someone says, well, you're running open source strategy or managing the ecosystem, what's that? And the deal is that, you know, open source software projects are not just the code that gets checked into the repository. There's a lot of dynamics in growing, managing communities, aligning governance, and all those things outside in the project. But also if you're an enterprise or a large other company otherwise sponsoring a project, there's a lot of work that needs to be done in terms of internal alignment and strategy to get the value out of it as a business as well. So in particular, I learned a lot of this at my time in Google, where we had, you know, important open source projects out there in the community, Istio, Knative, Kubernetes, and things like that. And how do you organize them so investments in that project in the community flow well back into engineering? How do you teach engineers to be open source citizens and contributors, all that kind of stuff. So that's what I spent the most recent portion of my life doing. And the other thing I wanted to mention is, although it's not strictly germane to security, I spent a lot of interesting time working in the big data and analytics space. And in particular, about a decade ago, the data analytics world was in this time where it was starting to get disrupted in the same way, you know, the clouds are disrupting enterprise right now. You had Apache Hadoop, Spark, really big, cheap, scale-out open source solutions that all of a sudden started to rival the incumbent world of like Teradata and data warehouses and everything for data analytics. And to me, at least, it's very interesting what's going on now, the way that Kubernetes and containers is changing the data center with what was happening to the small world of data analytics back then, and how initially the incumbents said it is useless, it's cheap, it doesn't work, it doesn't do X, Y, and Z, it doesn't do any of these things. But a lot of the industry and investment and focus moved toward it, and eventually the old world and the new world caught up. So I'm very interested as well in the security space right now, which is going through a lot of change in the same way, see if those dynamics will be similar to what we saw, or if there are any lessons I can bring forward. And of course, there's a legitimate application of machine learning in security as the attack surfaces and the number of signals grow all the time that is very much worth talking about too. So that's kind of where I'm coming from. And what I wanted to do was maybe, before we get to talking, highlight 3 things that I think are changing in our industry and 3 reasons why I feel that makes open source software very relevant to security. So there's a few things going on. One thing is what I just alluded to, and it's not a surprise in the Bay Area, right? The technology that the so-called hyperscale companies are using is becoming relevant and a default platform for everybody. You know, it happened first with Linux, and now we're starting to see it in the cloud with containers. That infrastructure, you know, originally invented to run at huge scale is now becoming relevant for people who are working at much smaller scale, and there's a lot of attention and investment, both commercially, but also in at places like the CNCF, where there's a plethora of open source components kind of building out this new version of the data center. And of course, even if you don't get involved in that at the hard end, what you're likely doing is consuming some sort of managed version of an open source standard where you're deploying up to a cloud, even if it's a serverless setup. So that's one change that's happening. Another one that you cannot have not noticed, because none of us really enjoyed those last week of December and early January this year, and that software supply chain concerns are now just a hot ticket item, with the White House bringing attention to it and dollars being thrown at this problem just to try and get a handle on it. So we do have this problem of how do you know your software can be trusted? And frankly, a lot of software with extremely low security levels on you know, verification of contributors and code that underpins a large surface of our infrastructure right now. I think it's something like 4 out of 5 CISOs now said, look, they had some kind of supply chain attack in 2021 happen to them. And with all this comes, you know, the usual sort of noise and hopefully good attempts at bringing together the industry to try and make progress one way or the other. And an important body in this is the Linux Foundation's OpenSSF organization, which has kind of emerged from dual investment, particularly from Microsoft and Google, as a home for this emerging set of standards and technologies and tools that can do something about locking down the open source supply chain. And there's obviously the software bill of materials, SBOMs, and SALSA are important technologies for us to kind of be aware of there. SALSA is this sort of externalization of GitHub, sorry, Google's internal controls about software safety. Third thing to just say about, you know, the situation that we're in is obviously cyber attacks are just ramping up year on year. The global situation is not helping, and you know, the number of attack surface from supply chain through regular phishing and all kinds of attacks mean that defense in depth is essential. Like, sure, we could all have wonderful certificates about the supply chain of our software, but at the end of the day, that's a promise. It's a promise that a human is somewhere made and they can be subverted, and we still need to be able to defend at runtime to get past these assurances. And this means, yeah, from the very software we build through to runtime, but it also means that because of that, the responsibility and awareness of security has to become more prevalent in an organization where developers probably never really cared a lot before. There's a lot of friction involved in that. And finally, we're in a tightening economic situation, so it becomes important to understand where to spend our dollars, and open source absolutely has relevance there. So there are kind of 3 kind of backgrounds that I think, you know, or a phenomenon that really affect where we're at right now. And I want to throw out 3 ideas on the value of open source in this space. And this is really, like, hopefully going to whet your appetite for the discussion. The first one is really about the fact that our new infrastructure for deploying applications is becoming predominantly based on open source standards as we move to the cloud. Or even if we're on-prem, we're looking at cloud compatible stacks like on-prem Kubernetes clusters. And so with that being the case, you know, there's immediate value in the security and monitoring infrastructure also should be based and built in open source at its core. open source gives us an ability to have insight, to reason about kind of the stack we're running, standards-based, and inspect it. The other thing that's clearly happening is if you paid attention to what's going on in the CNCF and Kubernetes and all these projects, like it's an explosion, very fast-paced new components, and being able to keep pace with that and potential attack surfaces and the way that open source evolves in all kinds of places, and there's no point of control. We need to be able to compete when we're deploying security solutions as well. And so an obvious sort of thought there is that open source can give us some of that potential velocity. We can attach it and security concerns to the infrastructure that's being developed at the same time and mesh the two. So it's clearly never going to fly to not be considering security and open source. So I think we need to be leaning in and seeing where it can be the best practice, the features, the thing that can keep pace with development as it happens. And the other thing, of course, is, the more people who are compromised, the more places attacks can be launched from, the more places data can be stolen from, and the more bad consequences later down the line. So, like vaccination, the internet's going to be safest when everybody is protected. And so we do have an interest in not just security being a pay solution, but for best practice on security and a certain amount of tooling being absolutely universal. So that's one of my first is where I think open source plays a very important part. Second one here is kind of the breadth and depth idea. Obviously, philosophically at its core, the fact that a piece of software is open source enables everybody to contribute to its evolution. This means that we can have security systems in which everybody can, theoretically, multiple vendors can contribute and make the solution better. That's not always strictly how open source really works, because the people who know the core and evolve the piece of software tend to be the people who do most of the work on it. But you can, in open source, set up very collaborative ecosystems where you don't necessarily need to be affecting the core of a system to make it work. But what you care about is where it connects to the things that you care about, like your own database environments, for instance, or some other part of your infrastructure. So, for instance, in the open source software project that, at Sysdig, and I care a lot about Falco, we have this idea of plugins. So Falco collects syscalls and has rules that look for anomalies. But what you then do is create a plugin ecosystem. So suddenly anything that's generating events can also channel events into Falco stream, and the rules can be more complex and operate over things. So now maybe you could start to look for anomalies in your cloud provider logs or in your event stream that you've hooked up from GitHub or whatever it is. But that architecture allows a lot of people creating systems to have them all feed into the place and get that kind of network effect of the rules and kind of the tooling. Basically, if we agree on more standards and really open source is the way that we are standardizing, then it means collectively we can then focus our engineering resource a lot more carefully and focus on things we know about and still make a meaningful contribution. We've talked already about kind of the need to put security in from runtime all the way back, rather the other way around, from development time all the way through to runtime. A lot of places where code is being written these days is pretty much open source, where all the IDEs are for the most part. And introducing security into that, I think, is a very sensitive issue, and it's very important that we do. And often the slightest obstacle to that means it won't be done. If we have to pay extra dollars to make our IDEs more secure, I'm not sure how much that's going to be done. We saw already last week the Python module, PyPy introduced a long signal change to require two-factor authentication on people uploading modules into that. And even that, like, most obviously common sense move generated a kickback from open source contributors who were, Some didn't like being told what to do. Some thought it was the thin end of the wedge. If they had to do this extra thing right now, what's the next bureaucratic step that's going to come from them? You know, and there's still this sort of lack of symmetry and expectation of people who are consuming open source and people who are writing it. As open source consumers, we want our open source to be secure. We'd like to actually be able to rely on it. But right now, we're curiously unwilling to pay for that. And so the cost tends to fall back on this sort of moral imperative on the open source developer, where they think it really, well, it's their, you know, freedom of expression to put open source out there into the world however they want. And if it gets adopted, great, caveat emptor. But there's a huge disconnect here because neither of those are realistic long-term views in the way the world's going. So we've got a lot of work to do to on that to kind of solve that. And there's a variety of ideas going around how we might do that, such as to have like a task force where the big companies can pay basically for people to fix open source and put grants out to make infrastructure more secure. At least we're starting to see some experimentation on how that can actually work. Anyway, that's a bit of a parenthetical, but to point out there's a lot of human problems around development and distribution of open source for us to worry about in terms of that upstream. But again, man, we know what developers are like. If the responsibility for thinking about security moves, as they say in the industry, shifts left further up to developers, then we need to be extremely sensitive to how this is a very human problem and a tooling problem in workflows as well. Finally, one good thing here, of course, is, you know, open source is a very well understood, I think, instance of a network effect these days. You know, collective intelligence. If one person creates something really good, everybody can use it. This suggests that if we pay attention to these root dependencies and clean that up, we get a very large bang for our buck as it ripples back out. And of course, by these days, by reason, that has to be done in open source. Just my third kind of contention why open source and security are very important together is this kind of move to polyglot environments. It's not universally true, but you know, contemporary software development, there's a lot of diversity of tools and platforms deployed. Sometimes that's even a deliberate choice. Very often it's one that just happens as well across teams and companies as they get larger. But one of those deliberate choices is always going to be multi-cloud or other instances of wanting to choose multiple platforms. And clearly, because of cost considerations and practicality, we can't be running 3 different instances or 3 different mutually incompatible ways of monitoring and remediating threats, depending on, you know, where we're doing it. Okay, there's one for Oracle over here, and then another one over there for something else. So again, there's going to be important economic reasons for us to standardize more heavily on, you know, things like threat detection, simply because of this effect of we need it to work over multiple environments, and we don't want to be locked into one, because as businesses, we want the assurance that we can switch vendor and we're not got that locked in and not generating risk really from that monoculture. So there's another very powerful place where open source can help us in security here. Like I said, just some ideas to throw out for the discussion. What I know is that I don't know a great deal, and I'm expecting to hear a lot of interesting perspectives from the room. So I think, Howie, this would be a good time for us to kind of move to discussion. I know you can see the faces in the room. Hopefully you'll help us moderate the chat as well as this goes on.
Perfect.
Yeah, I'll leave the slide up with some questions, some starter ones there, but I think wherever the room wants to take the discussion makes sense.
So Danny here, you know, something that you, so I've worked with open source and open source standards before with groups like the Open Group, ISO, And I haven't participated, but I know of IEEE standards. With those groups, does it seem to be a hindrance to work with those kind of groups and do it all internally? I know that one of the reasons why, Nokia or some of the other participants in like the Open group will participate in the Open group instead of using the standards independently, is so that coordination and coming together around the standard doesn't come at someone's compromise. If someone owned the standard and they made changes, then they could compromise other implementations of the open source. What's the kind of cost benefit from your angle about working with third-party organizations to moderate the open source standard?
This is a great question, because there is no one strict, when you say open source, there is no one strict flavor. There's a variety of incarnations from, there's some very well used open source where the Chromium browser is an obvious one, right? Or the Android operating system where there's one large company backing it, you trust it, but to some, because of who they are and the economic disadvantages if they misbehave, that aren't in their interest. And if open source is indeed becoming like the setter of de facto standards, there's this huge question of, well, how are they fair for everybody? And this, I think, is why we've seen the strong rise of the CNCF, which is the Cloud Native Computing Forum, that was kind of born out of the creation of Kubernetes and this establishment as a foundation under the Linux Foundation. And there, I think, is something that's a bit more of a compromise, a middle ground between, independent vendor development and something as intentionally slow as a real standards organization, is that it can keep more of the velocity of development, but still have multi-vendor, structures that encourage and indeed enforce multi-vendor participation in the open source software. So you kind of get in this proxy where it's still kind of vendored, right? But it's, that it's the CNCF, which is a certain degree of assurance, and you can look up and see, for everybody to see, oh, look, the top 3 companies participating here are Google, IBM, Red Hat, Microsoft, or something. That means something to me. There are standards. I'm not sure if I've answered your question, but I think we're seeing that it's very important to have the ability to have this multi-vendor assurance, especially for things that become extremely fundamental to the infrastructure, like Kubernetes.
Yeah, actually, I do have a quick question that follows on that. When I look at some of the larger open source projects that are like Apache, that the big 4, Google Cloud, Azure, AWS, that they wrap the open source, a lot of the committers on the open source are from those companies. Yeah. And so I always wondered about the ability to have them enforce some of these MFA or whatever and bring it in from that side, because they have a vested interest to make sure the open source that they're wrapping, putting commercial, services on top of, right? So I think maybe tails off what Danny asked. I don't know if there's, because it's, yeah, anyway, just leave it there. Any thoughts?
Well, you certainly got different ecosystems behind different projects where, I think Linux we trust largely because we trust people like Linus Torvalds or Leonard Greycrow Hartman or people like that who are open to, who operate, as project leads with a great deal of integrity and is subject to a great deal of scrutiny. Apache again has its own procedures, but other things, notably Node, and that world there is much less well developed in kind of that accountability or scrutiny, and things that have like highly decentralized package management ecosystems don't have a centralized point of release, which is where I think a lot of the things that we're talking about, controls become and procedures become very easy, or more easy, more tractable to implement there. And it's a highly complex problem because you know, in an organization and inside an enterprise, you're used to, you know, managers, you're used to rules and things you just have to do for your job. Out there in open source, you have to build all that again under the governance of whatever your collaboration is. So it becomes slower, more difficult. And to a certain degree, where there's corporate funded open source, some of it is highly reliant on volunteers as well, which makes it fragile.
So, I mean, I like what you're saying, but I'll play devil's advocate. Why should a big company that already has billions of dollars even work with open source when they can just hire people to do it for themselves? Like, because one of the issues I see with some open source projects is that unless you're dealing with one of the top real big ones that are popular, I know, for instance, nobody really invests in NTP research anymore or NTP security. So that's one of the weak points in who works in NTP open source. And I was talking to the lady who worked at the government for that, and they get almost no funding, and they, at one point, it was like a critical attack. So for me, and I also remember before the Heartbleed attack, nobody invested in OpenSSL, even though it was a critical function. So, like, how do we, I guess not why a company would, but how do we get more enterprise companies to do it more egalitarian or and less just in their specific interest? Because there are so many, to me, aspects of security solutions that we need, but we focus on the ones that are only driving revenue, like the Kubernetes and things of that nature.
Actually, I got a comment on that one. Oh, sorry.
Please go ahead in the room. Yeah, I don't want to.
One thing that I've always found very interesting. So my background is economics. I studied economics. Operations research is particularly interesting when it comes down to open source.
What is operations research?
So it's basically how you resource people, how you deal with business problems. It's basically like business analytics, but a little bit more focused on specifically operations resourcing and how you deal with certain cases. So operations research has a classic problem called the newsboy problem, in which you have you're a newsstand, you have to buy a certain number of newspapers, but if you don't sell all the newspapers at the end of the day, you get left with newspapers you can't sell because nobody's going to buy day-old newspapers. And so, it's a classic operations research problem. With resourcing people, it's the same way. You need to be able to hire enough staff to be able to cover all of your projects and expectations, but clients is going to, the number of clients and the number of client hours is going to fluctuate over time. You're still going to be paying for so many full-time staff or full-time equivalent. Open source, as far as I understand, has had an interesting benefit to a company to provide the flexibility for pulling a person on or off an open source project as a general catch-all for end resources that didn't get allocated to projects and other such things.
Yeah, it's interesting.
What we've come to realize is that creates zombie open source projects. Yeah. Because what ends up happening is, it's like what you said, like, like maybe when you're at Google, they told you maybe know about the like 30% rule or the 20% rule, or like Netflix, you have the 10% rule or whatever, where you can work on an open source or some kind of project on the side. That sounds all well and good when you're hiring people and when you're doing it, but when you start to depend on certain projects and those employees leave, those projects become zombie. Where you go to like GitHub and you see the last README date is 2-3 years ago, right? And so that's small, but obviously you're on open source standards, which I love the idea, but once again, I guess I like open source standards. I just don't like mandated standards, but yeah, like it.
Yeah, I think there is such a broad spectrum of things meant by open source, and I think it should be reasonable, right, to create a lens of maturity by which you can rank your risk in terms of adoption. You know, and we look at things like, are there people still working on it? Who are the people still working on it? Who are all the other users of it, right? If you know that Netflix is a user of it, for instance, you're pretty sure that it's in their interests to step up and help out if it looks like something is dying. So there's a comfort there for people. And that's what I think bodies like the CNCF, through having this kind of structure where they have projects that go from sandbox to incubated to graduated, can try and put some kind of imprimatur on the dependability or the sustainability of the thing that you're actually going to be relying on. The second thing I wanted to sort of say to add to this is I think what we will see is that there are people, there are some organizations who it is in their economic interest to do a lot of cleanup, and that's really going to be the clouds, where they're in a position now that already have their operate CI/CD pipelines that customers use. I think it's a very reasonable expectation that I go to my cloud and I say, I want to build my software on your pipeline, and I expect you to have fixed, to provide me with secure versions of the dependencies that I have for the most part. And that'd be something I pay for. And therefore the clouds have an interest in supporting that open source in the long term. They take that stewardship of, what's ultimately become like the global SDK, some of it on themselves. And you're seeing
Can I add one challenge I think traditional operation-based security teams have? Log4j comes out, Log4Shell or Struts vulnerability. First thing you do is like, okay, do we have a development team? Yes or no? Okay, do they use these libraries? Yeah, everyone does. We're Java programmers. We're not involved in the open source community. We just use what everyone else does to get this application going. Then you got to look at all the other stuff that's not in your pipeline. All these, like the load balancer uses Struts, and does our application server? Yeah, its management console uses that too. And there are all these open source things that vendors use that you may or may not be able to discover. So how do you maintain your inventory outside of the pipeline of the stuff you can control? How do you discover? Is there an open source standard that says if you use this open source library, you have to make it public information?
That's what the SBOM is good for.
Yeah.
Is it the open source license too?
Right. But sometimes that's not always easy to, it's just a thing that comes up. How does this impact us? And you start finding it's all over the place, right? Can you scan for it, or just ask all your vendors, do you use this in this version? When are you going to patch it?
See, because I know
we're at the infancy in that stage. We have these ideas of SBOMs and whatnot, but I think there's at least two competing standards. There's not very much tooling. Probably will pay attention when there's like a European Union or a federal purchasing regulation that you can't sell stuff without one of these, and then we'll all benefit.
So you showed SBOM up there, but you also showed SLAF or SLSF. What was that?
Salsa, yeah. Let me.
Yeah. What is that?
That is basically a level of assurance. It's slightly more. I'll try and see if I can just bring up the web page for Salsa. Because I could actually explain it badly. It's basically a set of maturity guidelines or kind of levels of trust you might have in operating software. So it has 4 levels, where level 1 is at least how the software is built is documented. Level 2 is where there's some degree of guarantee against tampering of the build environment. So, maybe your cloud hosts the CI/CD and can put some digital signature on it. And level 3 is like having this extra. This is very, this is very high level, but extra levels of resistance. So an example of that would be there's security controls on the host. The signature on your build is actually something you verify down to root trust that you've got. And then level 4 is highest levels of confidence and trust you're going to be able to have. So things like you would institute the guarantee that two people have always would have reviewed any code check-in, for instance, in the software that you're building, and that you can rebuild the software hermetically, sort of abstract and it's repeatable. This sort of framework, and there's a lot of detailed explanation and metrics on the site, which is slsa.dev.
Thank you.
But in its essence, it's an externalization of something called BCID, which Google developed internally for having different kind of security zones where code could execute inside its data center. And it's a very strong analog to that. And there's some tooling starting to come out about how it could enforce things like that, which I think then starts to speak to the previous question about how do you know what you're actually deploying and so on. Well, the thing is, you can, you start to be able to get tooling and policy and execution environments that could automatically enforce some of that assurance. What do you do with an SBOM once you've got it? You need something to be able to take a response to it that's proactive rather than you just, use them in a reactive circumstance.
I have actually heard of some edge cases that do push the some of the pain points of open source and security. One Black Hat convention speaker a few years ago, he talked about this isn't cybersecurity, but he talked about elevators in New York. And he said he can get into, he started figuring out how he could hack the elevator to bypass the security and just go to a floor that he wanted to. Now, one of the ways that he found out how to do that was that the fire department was having problems having all the keys for all of the override systems for all of the elevators in New York. It was just too much. And so what they did was that they unified on a single key, universal master key that the firefighter could use to unlock and move the elevator to whichever floor that he wanted.
That was the TSA key.
Oh,
Yeah. No, TSA
For real?
did the same thing.
For the box, for your suitcase.
Yes.
Yeah.
oh yeah,
It's
yeah.
like the TSA approved suitcases have to have a certain type of lock the TSA can open.
Yeah. Oh, yeah. And then you can override the. Yeah. So he figured out all he had to do was just make one of those keys, and then
Just make one of those keys.
That's it.
one key, and you could override any elevator in the city of New York, because they actually published online. They actually published the actual keys, the key tooth configuration. Yeah, it makes it so that so open source, for a lot of areas that you had worked on with Google, for example, like TensorFlow. Yeah, everybody agreeing on the same standard format for the data to be read out, so that if you run a TensorFlow model in one area versus another, that works just fine. But when it comes down to security, there does have to be some oversight over the open source implementation of a security protocol.
Yeah. The in the CNCF context, they're making some inroads towards that, and at least they have a requirement that there's been a security audit at least once during the incubation phase, but they're moving that towards requiring annual third-party security audits of their graduated software. So that's one thing that I know about. Obviously, in projects like TensorFlow that have a large internal component engineered at Google, there is a sub-team whose responsibility is security. And then, there's a lot of things out there increasingly adding fuzzing to, there's a movement to sort of add fuzzing is like just as a default in the build pipeline for prominent open source projects, and other people who are just, finding ones that are important and preemptively running the fuzzing all the time.
Yeah, one other thing, there are open source tools for checking the software security, right? OWASP has their 10, threats of what software, for SQL injections, things like that. And I believe there's other open source tools for checking whether you're putting API keys in the source code, or using environment variables as a place to store keys. So just open source is maybe its own, because a lot of people don't want to spend the money. Some of these tools for checking, like Synopsys, I think it is, has a whole suite around SAST and DAST, but there's open source variations. It just costs money. And I think sometimes money is a barrier, changing habits. But if it's an open source tool, it comes to its own rescue, maybe.
Yeah, I think that's kind of one of the central contentions I was trying to make in my deck, that a lot of the answers probably should come from open source because of the economic benefits of sharing this. These are not essentially unique problems. We all have them, and we all want to be able to take advantage of the research as quickly as possible, let's face it.
I do have a resourcing question, actually. So when it comes to Sysdig's efforts in the open source space, other than managing direction and coordinating resources effectively on different parts of building out the open source suite, for lack of a better word, how many people, other than management, how many developers actually are full FTE? Like, do you actually have full FTE developers, or do you kind of have everybody on mixing some kind of other for-profit line, like they're half on the for-profit line with some flex and half on the open source?
So we're not unlike larger organizations in this regard, in that there are a group of developers who are full-time employed on upstream, on Falco, as distinct from the commercial product. They don't touch the commercial product. As far as our engineers on the product are concerned, they're another open source project. It's quite well divided, because I think to maintain what Falco needs as vendor diverse project with multiple people engaging, it has to be in good faith in that regard. So yeah, there's upstream team, but then there are also many engineers, throughout product, particularly with things like Prometheus or OPA that we use, who are also in those communities and making upstream contributions, pretty much like, in the conventional way that you kind of get involved periodically in open source. So I think we're not unique, but in terms of having, created and trying to foster the success of an open source project with Falco, we absolutely have to have deliberate resource around that to get, to push it to its maturity. And you see that pattern inside of the large tech companies and also startups who base themselves around open source projects. One thing I'll add, since I got the soapbox on it, is, my point of view is actually that investment needs to be taken real seriously. If you want long-term success for these projects, and things like product management, program management, UX, documentation, all need intentional effort to make the thing work. And that's why you need to organize around it. That's not going to sort of organically happen in the long run.
I'd like to raise a very interesting topic that I think you'll get a kick out of, and maybe you have some thoughts. I teach a law class to some data science in a data science program. One of the things we talk about is, who do you sue if the open source goes south on you? So I would think that the companies that are going to commercially wrap it would want to make sure that it wasn't substandard somehow, right? Does that make sense?
No, because I see a lot of companies, to try to be first, would just take code that maybe untested, unproven. I mean, we've seen it in software time and time again.
But in the auditing standards for some of these things, they're supposed to test the software.
How long have you worked in Silicon Valley?
No, I know guys who, in highly regulated industries, they...
No, so you just said it. In highly regulated industries, you don't see a lot of open source code, though. You see some open source code, but the government, that's why the government came out with FedRAMP and everything else, is that they have to approve all of that stuff and do legal paperwork. But for making money, generally you would...
But if I'm AWS and I'm wrapping Elasticsearch, if there's an open source tool, that Elasticsearch is pretty ubiquitous as far as search and Kibana. And I know of a guy who he was in charge of compliance for Freddie Mac. and AI software.
Yeah, but you just said compliance again. Like these are once again formalized, regulated environments that are used to not being loosey goosey. But if you're a company that's doing T-shirts, and you can find some software that help you do it faster, who cares if you cut corners? I mean that's how I've been around people who do that. Now, when you're dealing with life or death situations or Fed, you're wholeheartedly right. You would want that to be a bit more robust and how people check it.
And doesn't Amazon have their own branches to all this stuff, and they layer on their own code that they don't publish back to the open source community? They just take updates and then branch off on their own that they deploy, so it's their flavor of Elastic or their.
If they do it, yeah.
But they're free to do that, right? You don't have to publish everything you do, right?
No,
You can just feed off.
It depends on the license and I'm surprised you didn't get into that, the licensing, because you can have the Berkeley license, you can have the FSF license. Each open source license may allow you to do that, or they may say any changes you make have to be opened up.
Yeah.
And Elastic's a corporation as well, right? Maybe Amazon.
No, so
That might not have been a good example.
No, they got screwed.
Huh?
Well, like solar.
I have a couple
Solar
of
is funding.
comments.
So, and I don't want to get into this too much, but I just know that as a general matter, it's come up in the legal community. Okay, just because I'm in the ABA committee on the big data and stuff, and not that it means anything per se, but there's been a lot of discussion in some of those committees on the liability of people who write open source and who gets sued. Because some people just write open source and it's not wrapped; it's just straight out of the box. And if it's not vetted, a lot of people do that actually. That don't go to a commercialized version. And I would want to make sure I had my own tests on that software, because software testing is a major part of the audits. I know, for example, model risk is a big issue. Predictive model risk. I'm talking about in machine learning. Risk is a huge topic for banks, and they have people come in and test that just to the nth degree. And some of those are built on open source. TensorFlow, some of the, anyway, I could get into the weeds on that, but as a general question, I just thought I'd raise it despite his.
But I know that Ed was getting ready to say something as well about that.
Yeah, well, I would say it is like this is a big topic of debate, right, in a variety of places. At the base level, you slap like an Apache license on your software or something, and the default licenses says, this piece of software comes with no warranty for purpose, and you read that, and the developer thinks they're covered, right? But of course, you can still put a lawsuit against anybody and contest that or whatnot. I don't think it's generally worth it for like a solo developer, and so the liability has to pass upstream to somewhere that someone's actually worth suing.
But it's the developers. It says it's an as-is thing,
Yeah, but I think it does create opportunity, right? So I do think you've already seen. I know Google will have, and other clouds will come out with, okay, here's a bunch of dependencies that we vetted and you can use, and it's not just that we wrapped open source when we delivered our Elasticsearch service or something. It's we've actually done that for these dependencies, and you can build on them if you wish. And you've got some startups doing that. Even there's one called ChainGuard, who are very invested in this supply chain security stuff, that are now their main product. I don't know if we're working on it, is tested base images, right? Like Alpine Linux that have been hardened and reduced, and that could be the base for all your Docker containers you could build on top of. So I think there's economic interest in people providing, there's still a network effect to be gotten in providing this some medium level of risk assurance that's better than nothing and less than what a finance house needs.
I do know one workaround. This is just food for thought. If you call it a beta, this is what Open Group has done before. If you call it a beta, then there is no implied warranty of the accuracy of the thing that you're producing. So sometimes you can actually see products that stay in perpetual beta because then it like the tool that I created back, it was like 2017. I created in 2017, It's still in beta today. So it's because you don't have to ever pull it out into a full release. You avoid the assurance and warranty of liability because you say it could have bugs that could cause a problem in your analysis.
That sounds good, but I have yet to see enterprise companies consistently use beta products.
I think ultimately
We all come from different backgrounds, so we see different things, right, Jimmy?
No.
Yeah, so it's like, I agree that if I was making the decision, one of the things I do before I use something is look at how many committers are there? When was the last check-in? You know, how good is their public forum and their documentation? If it sucks.
Is there a checklist for that, Ed?
yeah, I mean, there are a variety. I was actually just involved in a conversation on Twitter about this. There's a variety of metrics you can use. You could certainly find those checklists around. You can look at like the graduation criteria that the CNCF have for their projects, for instance. You know, different people have different ones, but like you said, like who's the committers? Is it fresh? Who else? Who big users are there? Is there a good community of people providing mutual help on it, et cetera, et cetera? There are a lot of social standards you can apply. Is it somewhere that you deem reliable, like an Apache project, or is it just a random GitHub page? So that there are definite ones. I just wanted to build on that last point. I know we're coming to time to say that I think this is a reason for us to not obsess on purely about like the those sort of pre-litigated aspects of risk management, like validation and whatnot, and also be looking very deeply on the detection and response side as well. So, because for all those systems that try and guarantee is something's always going to slip through, something's going to be socially engineered. Like we have to apply at all levels and be looking at the environments in which we're running our software, have them increasingly sandboxed, increasingly monitored, increasingly able for us to just sort of automatically shut down bad stuff when it happens, which is, again, this other part, I think, of open source and infrastructure engineering that is sort of exciting and interesting right now.
Ed, I thought you brought up a good point on your last slide. It was point number 2 about adoption. And my question is, or maybe the comment is, how many organizations know if they're using open source internally? And it ties into productivity, right? Like back in the early 2000s, how many CIOs knew if their IT team was using Wireshark, right? Like everybody wants to get their job done quicker. I feel like with the cloud native environments that people are running in now, they tend to lean on open source tools that are built for those types of environments versus what they may already have either that's on the shelf or being used by another vendor that maybe isn't necessarily applicable to cloud native environments.
I think you're right. There's certainly like a developer analog of shadow IT, right? That is just becoming rampant or even the norm in today's software engineering world, which is, I think, fundamentally why approaches like the SSF, approaches about hardening all our tooling, about bringing security best practice into every part of the development lifecycle is probably one of our best strategies going forward, because there's always going to be someone who finds some code. Probably, to this gentleman's thing, it's probably going to be an AI that's writing some code, you know, next month that's going to have some crazy hole that you cannot, you know, see.
It already exists.
Yeah.
And those third-party appliances all have web interfaces, and they all use open source libraries and stuff, like camera controllers and UPSs and all sorts of stuff you control over.
Hardware is the most worrying space for this, because there's typically a lot less attention to the software and even licensing. You know, never mind security than the software. So agreed.
Oh, well, yeah, a lot of this stuff is made by people who forget about licensing. They copy like Intel's code off of routers and stuff to make their own products, right? Remember there's a big router, Intel router vulnerability like 5 or 6 years ago, and they found that there's all this like illegal copied versions of that firmware on knockoff brand routers and stuff. Everyone was using it, had the same exploit, same vulnerability, because they're all copying like some Intel code from a licensed product.
You're talking about Mirai botnet.
Yeah, but they discovered that it was like all these cheap brand routers were using the same exact firmware without a license.
Thank you very much, Ed. This
Yeah,
was
what do
great.
we, so Ed, what's your words of encouragement? What's our, what do we do to keep?
Honestly, I think keep telling people what you need, right? Keep the dialogue going. I think we all want to be, everyone is involved in open source, and particularly the industry collaboration, want to understand what people need and what the biggest problems are to focus on. And we want to understand, I think, as well, how we can help address not just the technological, but the human and organizational aspects of these as well. So I think the best thing to do is take a look at the dialogue, see if there's some place you can have a voice in what's going on in places like the Open ISSA.
Thank you very much. It was great having you.
Thank you.
Thank you, Ed.
Thanks for having me. I really
Thank you,
appreciate it.
Sysdig.
Still like his background, actually.